Why is very less quantity of heat energy produced in connecting wires? Now, connecting wires are made up of good conductors. And because they are good conductors, like copper and aluminium, they're made up of copper, aluminium, and they have low resistance. And as they have low resistance, they produce less heat. Which one has more resistance, a 100-watt bulb or a 60-watt bulb? Now here I have a 100-watt bulb and this is a 60-watt bulb. Let me see which has got more resistance. With the formula for power is V square over R. So for this 100-watt bulb, it would be, power is 100, and so this would be V square over R. So the R here would be V square over 100. Now in this bulb, again the same formula, power equal to V square over R. The power is 60, V square over R, and the R is V square over 60. Now in one case we have V square over 100, and the other case we have V square over 60. Which has got more resistance? You'll definitely agree here, this is more resistance. The 60 watt will have more resistance, the 100 watt will have less resistance. Since the voltage we consider to be same, this voltage is considered to be the same. So higher the power, less is the resistance. Higher the power, less is the resistance. However, in this case, the V remains constant. The potential difference is constant. So which has got more resistance? The 60, we'll raise this up, the 60-watt bulb has got more resistance. How much energy is given to each coulomb, means 1 coulomb, charge equal to 1 coulomb, while passing through a 6-volt battery? So voltage is 6 volt. Energy means work. Work, energy are interchangeable. And we know the formula for, this is the expression, we know V equal to WQ. So we have our V is 6, the W work we need to find, or energy we need to find, and this is C is 1 volt. So the work will be 6 over 1. So the amount of energy, work or energy, will be 6 joules. So how much energy is given to each coulomb of charge passing through 6 volt battery? The answer is 6 joules. What determines the rate at which energy is delivered? Is power. We've learned in the last test also, power is the rate at which energy is consumed. Or dissipated. That's why power equal to energy over time, or work over time. What does an electric circuit mean? Here is a diagram of an electric circuit. It's a closed, continuous, conducting path of electric current. In the first figure, we see that the circuit is closed. So the current flows from positive to negative. However, we've learned that the electrons, and it is closed, electrons flow from negative to positive. So the bulb now begins to glow because the circuit is closed. It's a continuous closed circuit of conducting material. In the second diagram, we've seen the open circuit, and here the current does not flow. There is no continuous flow, and hence the bulb does not glow. So this is an open circuit here. It is open, it's not continuous, hence it is open. there is a break here made by the switch. So the first is the open circuit, the second is open circuit, the first is a closed electric circuit. Define the term electric energy. Here, electric energy is energy obtained due to a difference in electric potential. It is the work or energy consumed by an electrical device. Whenever there is a difference in potential, current begins to flow, and as this current flows, an energy is developed. This energy can be used to do work. This is called electric energy. So I repeat again, electric energy is energy obtained due to the difference in electric potential. It is a work or energy consumed by an electrical device. Now, to find the expression, the next part of the question is to find an expression for electric energy or for the work done. So let us consider a current I flowing through a resistance R. Let V be the potential difference and Q the charge flowing for time t. We already know that work is potential difference into charge, means W, which is electric work, equal to V into Q. So this is an expression for electric energy. We can go ahead also, and we know that I equal to Q over T. So Q equal to IT. Now we substitute this value. So W work equal to V. For Q, I'm going to put IT. So we can take electric energy W is also equal to VIT. What is meant by power rating of an appliance? Power rating of the appliance means the rate at which that appliance consumes electric energy. So here once again, power rating of an appliance is the rate at which the appliance consumes energy. How much of energy it consumes per second. A bulb is rated 60 watt, 220 volt. What does it indicate? So here it is a bulb which is 60 watt and 220 volt, means when it is connected to a battery of 220 volts, it consumes 60 joules per second, means 60 watt. It burns, as it burns, it consumes 60 joules per second, means 60 watts when connected to 220 volts. Let the resistance of an electrical component remain constant, which means if the first resistance is R, in the next case also it is R, while the potential difference across two ends decrease to half its former value. So if the potential difference is V, in the second case it is V by 2. What change will occur in the current? Now we know the expression that V equal to IR. So which means I equal to V over R. So here also I'll write I equal to V over R. Now in the first case we call it I1, and this is V over R, and this is I2. However, here the V is not V, it is V by 2. Have you seen the V is made half over R? So if you simplify this, this becomes V over 2R. Now we do I2 over I1. Your I2 is V over 2R divided by I1, that is V over R. So I2 over I1 equal to V over 2R into R over V, and this becomes 1 by 2. So we have got here I2 over I1 is 1 by 2, means I2 is 1x and I1 is 2x. And very obvious from here that the current has become half. If voltage is dropped, the current also becomes half. So we see here the current has become half its original value. I2 is half of I1. A piece of wire is drawn by pulling its length. So its length is doubled. Compare the new resistance with the original. So here first we had one wire, say like this. The length of it was L, and the area of cross section, say, was A. Now the same wire is pulled and made longer, so definitely you will agree it becomes thinner, so it becomes and double the length. So now the length is 2L. Let's see what happens to area of cross section. See, area of cross section is A1, here area of cross section is A2. Now the volume is the same in both the case because it's the same metal that is pulled. Here volume in the first case is area of base into height, and second case area of base, that is A2, into height, that is 2L. So the L will cancel, so A1 equal to 2A2, which means A1 over A2 equal to 2 over 1. So we can say that A1 is 2A and A2 is 1A. So I'm going to put that here. The A1 is 2A thicker. This is 2A. And here is 1A. Now let's compare the resistance. In the first case, R1 will be rho L over A, and R2 will be rho. Now L here is 2L and this is A. However, in the first case the A was 2A, right? Now we'll do R1 by R2. Rho L 2A divide by rho 2L over A. So R1 by R2, rho L over 2A, division becomes multiplication. You take reciprocal, and then you will find R1 over R2 is 1 by 4, which means R1 is 1x and R2 is 4x. So the resistance in this case, first case, is 1x, and the resistance in the second case is 4x. So you'll definitely say the new resistance is 4 times the original value. So here the new resistance is 4 times the original value, means R2 is 4 times R1. Draw a circuit diagram with a cell, electric bulb, ammeter and a plug key. So here's the circuit diagram. This is the bulb. Here we have the ammeter. This is the plug key. And this is a cell. However, this is not a cell. Here's a battery, right? So I think for this you should have drawn only the one. We'll do it in a dark. This connected here, because this is a battery. What is important? Put positive, negative. Now this should be negative, this should be positive, and the current C is flowing from positive to the negative. For a heater rated 4 kilowatts, so 4 kilowatts is power. So I put power here, 4 kilowatts, and I'm going to turn it into SI unit, that is watts, so it is 4000 watt and 220 volts. So potential difference, or V, equal to 220 volt. We need to find the current. So we have the formula P equal to VI. The P is 4000, the V 220, and the current is I. So it will be 4000 over 220 amperes will be your current, which is 18.18 bar amperes equal to the current. Next we go to find the resistance. So for the second one, to find the resistance, I will use a power V square over R. Since the voltage is given to you, I'm using the formula. There's another formula for power, is I square R, but I'll use V square since V is given to me. So power here is 4000 watts V square 220 square over resistance. So resistance equal to 220 square. So 220 into 220 over 4000. This will be your resistance. And in this case it is 12.1 ohm. And for the last part is the energy consumed in 2 hours, that is C. Now energy consumed is power into time. In this case I'm going to use it in kilowatt hour, so the power I will do in kilowatt and the time I will do in hours. Therefore the energy I will get kilowatt hour. So the power for kilowatt is 4 kilowatt, time is 2 hours, so it will be 8 kilowatt hour will be the energy consumed. You could find the energy in another way also. You could find, if you take the power in watt and time in second, then you will get your energy in joules. That is the SI unit. So I'll do that too. So energy is power into time. So power, if I do in watts, it is 4000 watts. If I do in time, in seconds, it will be 2 into 60 into 60. Now whatever answer you get here will be in joules. These answers in joules are so large, that is why we prefer to use kilowatt hour. A lamp of 100 watt, a toaster of 50 ohms and a water filter of 500 ohms are connected in parallel to a 220 source. What is the resistance of an electric iron connected to the same source that takes as much current as the 3 appliances, and what is the current through it? So here the R1, we will take it as a toaster. R2, we take it as R1 we take as a lamp. So R1 we took as a lamp, R2 as a toaster, R3 as a filter, and you see they are connected in parallel. So to find the resistance, we'll do 1 by R, R1 plus R2. I have solved the sum earlier from the NCERT solutions. So I have 1 by R equal to 1 by 100 plus 1 by 50 plus 1 by 500. And on doing this calculation, you will get your R as 500 over 16, which is equal to 31.25. Now both these circuits, now it's given here that the current drawn by both this is the same. So current drawn in this circuit and this circuit is the same. If current is the same, I is the same, and the V also is the same, hence the resistance also should be the same. So this resistance of R equal to 31.25 ohms is also the resistance of R4. This also will be 31.25. Since voltage is same, current is same, so resistance also should be the same for both the circuits. Now to find the current, we use the formula V equal to IR. We know this is 220 volts. The current we don't know, the resistance is 31.25. Therefore the current becomes 220 over 31.25, and the answer for this is 7.04 amperes. I've explained the sum in more detail when I did the NCERT solutions. What are the advantages of connecting electrical device in parallel with a battery instead of connecting in series? So first, the voltage is the same. When you connect in parallel, the voltage remains the same. Like in this case, we've seen here we have the bulbs, and all these bulbs have the same voltage, 120 volts. For this also it will be connected to the same point, 120, and the third bulb also is connected to the same point, 120. All have same voltage. The voltage remains constant. Next point, separate on and off switches can be applied to each device. Here we have 3 bulbs. We can put a separate switch here, a separate switch in each one. If we keep this switch open, then only these bulbs will glow. This one will glow, this bulb will glow, while the third one will not glow. If we suppose close this switch and keep this switch open, then this bulb will glow, while this bulb will stop glowing. So a separate switch can be attached to each appliance. The next point is the total resistance in parallel decreases. Hence a great current will be drawn, because we know the formula 1 by R equal to 1 by R1, 1 by R2. So the resultant resistance R is always less than R1 and R is also less than R2. So the resistance decreases. So there is a great current passing through the circuit. Next, the last point is, if one electrical device is damaged, then the other devices continue to work properly. This is very clear in this diagram. Here in this diagram, it's a parallel connection, and this bulb has stopped working, but the other bulbs continue working. But in the series, there is a break at this point. So all these bulbs have stopped working. Only 2 bulbs are working. So here in parallel, if one device stops, doesn't mean the other device also stops. They will continue working. But in series, since they are connected end to end, in this manner, end to end, if one of them breaks, all the rest here will stop working. Another important point which is not mentioned here, when the current I flows, it flows in many different arms. So if suppose we connect, in this case, we have a geyser here. In this case, we have a computer connected. Here we have a bulb connected, and maybe we have a television connected. Each one will get different current. The geyser will draw large current, the computer will draw less current, the bulb will draw even less current, and the TV will draw moderate current. So each appliance draws the current that it requires. But if they were connected in series, then what would have happened? Suppose we had a geyser and a bulb. The same current would flow through the geyser and through the bulb. And the geyser, we know, draws a lot of current. If that large current went to the bulb would fuse. Now if we pass less current, because the bulb requires less current, it is not sufficient for the geyser to work. So this is a disadvantage of series. Same current flows through all the devices, but when it comes to parallel, different currents flow in different devices as per the device. A geyser will pull in large amount of current, a computer will pull in different less current. How can 3 resistors, 2 ohms, 3 ohms, 6 ohms, be connected to get 4 ohms and 1 ohm? So the first I've connected them all in parallel, and you know the formula for parallel, 1 by R equal to 1 by 2 plus 1 by 3 plus 1 by 6. So 1 by R, LCM 6, so 3 plus 2 plus 1, 1 by R, 6 by 6, R equal to 1 ohm. So to get 1 ohm, I need to connect them all in parallel. Now in the next case, I probably will do this. I have to get 4 ohms, so I'll connect 2 of them in series and then the combination in parallel. So I'll have 2 here. Now that earlier diagram would do, we have to do it. This is just trial and error. So you need to keep on trying in different ways till you get the right answer. So here I take 3 ohms, 6 ohms. So when I do this calculation, I get 1 by R equal to 1 by 3 plus 1 by 6. So 1 by R, I get 6 here, 2 plus 1, 3 by 6. So R equal to 2 ohms. So we'll draw again. This is my 2 ohms, and here again I have 2 ohms. So the total resistance will be 2 plus 2, 4 ohms. So if I connect it in this manner, to be 2 ohms here, 3 ohms and 6 ohms, I will get the resultant of 4 ohms.